Good afternoon, esteemed guests, respected faculty members, dear participants, research scholars, and students. I, Chandni Kataria, delighted to welcome you all back for the second day of this enriching faculty development program on the topic recent developments in pure and applied mathematics on the behalf of IIST. I hope you all had a productive, insightful first day. Let us continue to learn, grow, and explore new horizons together. It is my distinct pleasure to now introduce our esteemed speaker for today's session, Mr. Upendra Kumar Tiwari. Welcomes you, sir. It is bringing over 16 years of expertise in training and project development. He excels in generative AI, data science, machine learning, deep learning, and related technologies. A highly skilled professionals with certification from IBM, TensorFlow, and Microsoft. He has delivered impactful training sessions to corporates, academic institutions, and students. Some other certificates and technical expertise in this field: Microsoft Azure Data Science Professional, Data Science Master Certification from UTM University, Malaysia, Data Visualization with Tableau, UTM University, Malaysia again, Social Network Analysis, NITTR, Chandigarh, Artificial Intelligence, IIT Nagpur, Data Analytics and with Python, IIT Kanpur, and other areas of contribution, designing and development of course content, design book and PPTs content for data science and machine learning, other training and mentorship, corporate training, like conducting session for leading companies such as TCS, EXL, ITC, Deloitte, Colgate, and many more. Delivered specialized generative AI training to EXL Noida, Dosri Noida, and IIT Kanpur, and including student training, mentored 1,000 plus final year student in project development, delivered summer and winter training to over 22,000 students across 50 plus colleges and institutions. Faculty development programs include delivered 60 plus FDPs online and offline covering generative AI, advanced machine learning and data science, and some other workshop, organized workshop in 50 plus institutions sharing hands-on expertise in AI and data analysis model. Other notable projects of Sir: human flow counting, crop price prediction, Twitter hateful speech identifier. So, sir, your remarkable achievement and contribution are truly inspiring and it is an honor to have here with us. Now, without further ado, it is my pleasure to hand over the session to sir and distinguished speaker, Mr. Upendra Kumar Tiwari, sir. Again, welcomes you, sir. Thank you.
Thank you, ma'am, for the nice introduction. I really thank you to you. And now let's start. So before that, good afternoon, everyone. And I just wanted to know before that what is the topic of today's session. Let me show you first. So everyone, the role of mathematics in future technological innovations. And as you've seen that when ma'am was introducing me, there were most frequent word and that was data science and machine learning. So somewhere, you know, that right now there are 5 to 6 emerging technologies. Like we have the blockchain, we have the AI, we have the cybersecurity. So, you know, it means you cannot ignore the importance of AI. And if you go to the hierarchy of the AI, so this is AI, and the subset of this AI is what? It's a data science. And the subset of this data science is what? It's a data mining. And the subset of this data mining is what? ML. And obviously, the subset of this ML will be deep learning. Machine learning subset is deep learning. So why I'm talking about this? The main concern is why I'm talking about this. Because, you know, whatever developments are going on in this data science, whatever libraries are coming, whatever applications you are coming up in this data science, you cannot imagine these applications without taking the mathematical concepts. So, dear sir and ma'am, there are two kind of communities who are using this AI at world level. One, who are simple a user, another who are actually the developer, AI developer rather I'll say, or AI engineer, whatever name you give, a data scientist, whatever. And if I talk about this now, so no one can complete their code without using this mathematics. And now I tell you one thing that this AI has becomes very buzzword. This data science has become a very buzzword. And basically what is happening, let's say, you know, in actual here, we have this data science and the role of or application of the data science, you can say except mathematics. And this is the mathematics. This is the mathematics. It means the main application in the data science concept is this mathematics. And when you combine it, so actually we guys see this as the data science. But this volume and the size that you have scaled here, it is not because of the new concept in the data science. It is because of the mathematics incorporated here. So dear sir and ma'am, why I just wanted to showcase this diagram somewhere, if you want to become a very good data scientist, if you want to do excel in the field of the data science, first of all, your responsibility is to know the mathematics. Why I'll tell you. Why I'll tell you. But before that, I just wanted to know, sir and ma'am, do you have any input that how this role of mathematics is there in this data science? Because as a future technologist, I am considering the data science and machine learning. So any idea from anyone? He or she can raise their hand. How this mathematics could be applied in data science and machine learning? Any idea? You can raise your hand if you want. I can unmute yourself. Matrix mapping. Very good, ma'am. So Ms. Ruchika has said matrix mapping. Again, concept of matrix. Yes. Another one. Very good. Sarulata ma'am, it's in the form of the statistic. Awesome. In the form of the data visualization. See, data visualization is the graph and chart, but yes, you want to showcase your statistical data for this. So regression analysis, awesome. Related to the machine learning. Yeah. See, any model, if you, any model is there in the machine learning, that is actually the mathematical model. So whatever terms you are writing, I cannot deny. I cannot deny, and I can only showcase that how we are incorporating mathematics over here. Otherwise, each and everything that you guys are telling, it is 100% correct. I will even not say 99%, 100% you are correct. So I'll come to you now. Yeah. So see, these are certain codes, which is what? That mathematics as the back. So when we are going to cover this session, so basically I'll just discuss that how you cannot imagine this data science and ML without mathematics, because the mathematics is nothing. It's a backbone of the data science and machine learning. Yeah. Okay. And whenever you have to work on the any innovations or any invention of new library, That is actually, you can say, the new application of the mathematical concepts. Fine. Then, I'm going to showcase one Python code that will actually be using the data science concept that would have been implemented to mathematics in backend. Yeah. So let's dive into the agenda, and I'll welcome your questions even in between the session as well as after the session. Yeah. So you see, here, when we are talking about this importance of mathematics in technology, I'll simply go to the data science. And here, I tell you that whenever it comes to the data science, basically, we do stages of, we actually do the analysis in 4 stages. We do analytics in 4 stages. And what is that? The first one is descriptive analytics. Then we have the diagnostic analytics. And then we have the predictive analytics. And we have the prescriptive analytics. So why I'm talking about this, the first thing? Yeah, so I'll just talk about it. But before that, I just wanted to know, what is analysis? Anyone? What is analysis? Yes, sir and ma'am, any answer? What is analysis? Drawing conclusion, okay. Study of happening, very good. Driving result from data, very good. To conclude, okay. Careful examination, 100% correct. Okay. So, sir and ma'am, make me correct if I'm wrong. So, can I say that analysis means I have certain questions in my mind and I want to get the answer of this question. I want to get the answer of this question, and that is nothing, it's an analysis. Yeah. So, whenever we do this descriptive analytics, yeah. So, whenever we do descriptive analytics, so basically the question that roams in our mind, it is what has happened. Yeah. So again, Dr. TD, to know about information means what? There is certain question roaming in your mind. Yeah. And when you got the answer of that question, means you got the information about this. So what has happened? This is your descriptive analytics. And why it has happened? Why it has happened? It is your diagnostic analytics. And on the basis of the same situation and scenario, if the same situation and scenario will persist, then what will happen in future? What will happen in future? If you are doing that, it's a predictive analytics. And obviously, you want to have, have control on this futuristic problem. So what you can do, you can list out the solution, and the analysis behind that is what? It is the prescriptive analytics. Even whatever solution have been proposed, you want to optimize it. There is a role of prescriptive analytics. Yeah. So in this way, we can work on. In this way, we can work on. And why I'm talking about it? Because every stage, whatever we do, actually there is the role of the mathematics. For example, let's say I'm talking about the descriptive analytics. So whenever a data is being given, So what exactly we do? We try to do some basic analysis. And if you'll talk about that basic analysis, so you can see that actually we are trying to examine our data with difference in respect to the mathematical concepts. Yeah. So for example, let's say we have the data. Yeah. And we are doing the descriptive analytics. So whenever we do descriptive analytics, basically we do 5 business moment decision. We do 5 business moment decision. So when I'm talking about the first business moment decision, so it is actually the measure of central tendency. Measure of central tendency. And you know that in the central tendency, we come up with the mean, median, and the mode. And if I talk about the second business moment decision, so we talk about the measure of spread. And you know that here it comes as range, interquartile range, variance, and standard deviation. When we talk about the third business moment decision, so we are talking about the skewness. Yeah. When we are talking about the fourth business moment decision, this is what? It's a kurtosis. And for the fifth one, we use correlation. Yeah. And correlation means what? You must be knowing about the Pearson correlation or something else. So you can see that whether I'm talking about the mean median mode, whether I'm talking about the range, interquartile range, variance and standard deviation, or skewness, or kurtosis, or correlation. Here exactly the mathematics is working behind. For example, what is mean? Sir and ma'am, what is mean? Anyone? What is mean? Average? Is it? So if you have to find out the average, that means what? You'll be doing the mathematical calculation. If you have to find out the mode, you'll be doing the mathematical calculation. So, and I tell you that this mean median mode or whatever we are seeing here, they're really very important in terms of doing the data analysis. Doing the data analysis, yeah. Now I hope somewhere I have been success to align that why this mathematics is needed in the data science and data analysis. I show you another example. You are 100% correct, Sonia ma'am. Stats is never accurate. Who is talking about the accuracy? We are trying, see, we are never claiming that we'll be 100% accurate. We say that we are 95% accurate. 95% accurate means you will have to be ready for 5% consequences, 5% error. This entire machine learning, this entire data science says that we are never 100% correct. So there are a lot of things. There are a lot of things. I'll talk about it. But right now, I'm trying to, tell you that why this mathematics is needed. Yeah. In medical, see, even when doctor gives treatment, when you know when doctor is taking care of any patient, do you think that whatever prescription he's writing, whatever prescription he's recommending, that will be 100% fruitful? Huh, Sonia ma'am? Do you think that that will always be 100% fruitful? No. Even I tell you one example. You must be knowing, or I tell you, there's a company name is Dockery. There's a company name is Dockery. They actually, develop the app related with healthcare. and doctors are using it. Even, Practo, yeah. So these are what? These are the app which are taking the help of the statistic. Yeah. So even Dockery, they build the app and doctors are using. Not doctor, even, when the patient will be giving his or her information, according to that, this app will automatically suggest the medicine on the basis of the past history. So I am not saying that this will be the 100% correct, but yes, the accuracy is somewhere near to the real. Somewhere near to the real. Yeah. Okay. So I show you one example. So whenever, we are incorporating this mathematics in our data analysis, what is the purpose? The purpose is what? To attain certain business objective, isn't? So, dear friends, whatever business we are running on this planet, what is the objective? So the objective could be either the objective is to either maximize the profit or to minimize the sales or my bad. It should be, maximize sales. Yeah. Maximize the sales or might be, you want to maximize customer satisfaction. Yeah. Or you want to minimize cost. Yeah. Yes. Yes, Ruchika. Ma'am. So you want to minimize loss also. So for this purpose, what you do data analysis. Yeah. So that while doing the analysis, you can get some lead, and that lead will be helping you out to get the result. Yeah. To get the result. So one example I'll show you. Okay. For example, let's say I'll just showcase one case study of the Walmart. So let me show you. Yeah. Just everyone just read this three line. Just read this three line. So the legend says that a study was done by a retail grocery store. The findings were that men between 30 to 40 years in age, shopping between 5 p.m. and 7 p.m. or Fridays, who purchased diapers were most likely to also have beer in their carts. And this motivated the grocery store to move the beer as well closer to the diaper, and instant they witnessed 35% increase in sales of both. So first of all, everyone just wanted to know, do you think that this is common? The relation between a diaper and the beer, is it common? Yeah. Do you think that there's a relation between the diaper and this is not common. Possibility is everywhere, but this is not common, isn't it? But when they have analyzed their data, when they have analyzed the transactional data, they got this answer. Yeah. Now, everyone, why the man between 30 to 40 years in age only? It's a US data. It's a US data, and okay. So it's a US case study, I can say. I'm asking why between 30 to 40 years? Anyone? Why between 30 to 40 years? Ideal age for being a father. Very good. Why between 5 p.m. and 7 p.m.? New parent, okay. Why between 5 p.m. and 7 p.m.? It's a yes, 100%, yeah. And why on Friday? Because it's a weekend. So can you see that this factor analysis have been done? And on the basis of that, when they kept this beer just beside of the diaper, they witnessed the 35% increase in sales support. So this is how a data analyst is doing. But now, do you know, or can you say, yeah. So, Dr. Ritika, can you tell me what mathematical concept may work behind it? What mathematics concept may work behind it? Hmm? Okay, how many of you know about association rule? Yes, this is the association rule. This is here. The association rule is applied. That is also called as the affinity analysis, where actually background a priori algorithm works, which on the basis of the support, consequent, and lift ratio. Yeah. So that is working, you know. So why I'm talking about it? It means, you see, we as a data analyst, we as a data scientist doing this, yeah, and taking the package in terms of, 40 to 50 LPA. But actually, the concept behind this is because of a statistician, because of the mathematician. So I really, thanks to these guys, because of them, I'm getting my bread and butter. Okay. So I'll come to that probability also. Let's say, Sarah ma'am, for example, uh, in a call center, okay, or let me ask this. Say, if you want to find out that what is the chance that any random student, if he attempt 10 question, if he attempt 10 question, out of that 10 question, 8 question will be correct. What is the chance that if a student attempts 10 question, then out of this 10 question, 8 question will be correct. So here what is there? That there is the probability coming into picture, isn't? And this probability is really very, very important in terms of the industry relevance. Why? For example, let's say in a coffee shop, we find out that on average per day, 50 customers are coming. In a coffee shop, let's say per day, 50 customers are coming in the shop. Now, what is the probability that today there will be 60 customer at my shop? What is the probability that today 60 customer will be at my shop? Yeah. So I just wanted to know what kind of probability distribution will be applied here. Anyone? Can you tell me the answer? What kind of probability distribution will be applied here? Yeah. So this is Poisson distribution. No? Thank you. Thank you. Thank you. I really, you know, I'm really happy as well as I'm really delighted to have this awesome audience. So yes, here the Poisson distribution will come into picture. And in this case, and in this case, that out of the 10 question, what is the probability that 8 question will be correct? Here, binomial, isn't? Because we have the fixed number of trials. Yeah. So see, this is the mathematical problem, but we are using this mathematical concept in our decision making. In our decision making. Let's say today I can, in my shop, 60 customer can visit. So what I'll do, accordingly, I'll maintain my stock now. I'll maintain my stock. I'll be having the raw material in my stock. So this probability can help you out to, you know, uh, to somewhere raise your business, to take some decision. Yeah. Okay. Another thing, everyone, all of you are from mathematics now. Yep. Everyone is from mathematics. Now, my question to you, what is normal distribution? Let's say, everyone, yeah, that is correct. It's a bell-shaped curve. Why I'm talking about it? See, what is this normal distribution? Everybody can tell me. The mean equals to median equals to mode. Yeah, bell-shaped curve, Gaussian curve, everything is correct. Yeah, it is used for continuous data. Everything is correct. This is not my cup of tea because you are the expert one. I just wanted to know that let's say I'm maintaining the data of a mutual fund. I'm maintaining the data of the mutual fund, and here when I draw the graph, I draw the graph of getting the money after, uh, uh, so I'm just trying to draw the graph of the money that I got back in mutual fund. Yeah. And I'm seeing that the graph is bell-shaped like curve. The graph is normally distributed. So my question to you all, what does it mean? What does it mean? Yeah. So Professor Sonam, this is what? This is the mathematical interpretation. Now, I'm saying that when whatever investors are there, when they invested in the mutual fund, after that they got the money back. So when I plotted those number, then I got this normal distribution. What does it means? By plotting this, how you will conclude, how you will interpret about the mutual fund. This is my question. So I tell you that whenever you plot a data, and if you're getting the normal distribution, then mathematically you can say the mean is equals to median equals to more that you already have said. But with align with the business problem, I can say that there's no risk in this. Yeah, there's no risk. Yeah, but in the same time, that means there's no risk. And let's say instead of this, I'll take another example. Let's say, Saran ma'am. Yeah. I hope this PPT is visible. Say you are the owner of the Netflix. Okay, you are the owner of the Netflix, and when you plotted, when you plotted the age, when you plotted the age of your viewer, yeah, so you are getting this kind of curve. Or let me make it the another one. You're getting this. So my question is it normally distributed or not? First of all, is it normally distributed or not? No. There is a skew, right skewed. It's a right skewed. Okay. Now everyone, as I've said to you, that you are the owner of the Netflix, and this is the graph that is showcasing the age of the customer. Say this is the say 18, and say this is the 40, and this is, let's say, 58. Okay. So on the basis of this, what is your opinion? Where is the population between 18 to 40? Isn't everyone? Where is the population? So the population is in between 18 to 40. Yeah. And very less people are, beyond the age of 58 or 50, 60. Very less people, there is a skew, there's a tail formed for the people who are having age greater than 60. Now let's say you have 20 million budget. You have 20 million budget. Now my question is, will you populate your library with the latest movies and series, or you'll be populating your library with the old movies? This is my question. Okay. So Mr. Kumar Sen is saying latest one. All right. Others? Yeah. Yes, yes, yes. Yeah, I totally agree with you. So some of you are saying that latest, but can I say that competition will also be there in this age group? Competition will also be in this age group now. So even though the mass population is here, but I think all the competitors like Amazon Prime, Hotstar, Geo, they will also be targeting these customers now. Yes or no, everyone? Okay. Now, another is, can I say that these people are the retired people? Yes or no, everyone? Yes, 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 yes. There is someone who has said that I would try to increase the, yeah. So, that means they have sufficient amount of time to spend. Yeah. And they are not going to compromise with their choice. So even if just for the old movies, if you charge some extra money, they're ready to pay. Let's say for the normal user, there's a 150 rupee per month subscription. And if you want to watch the old movies also, the subscription is rupees 180. So I'm pretty sure that these people will be happily paying this one. Yes or no, everyone? Yeah. So why I'm talking about this? See, that decision will be taken by the client and the data analyst. But here again, you're finding out that whether your data is skewed or not. You're talking, yeah, you're trying to find it out through math, through the help of the math. Yeah, with the help of the math. Yeah. And in another way, you can say that this mathematics is helping the business to take their decision, to take their decision. Now, everyone, another question. So, guys, I hope that you guys are not feeling bored. Yes or no? Okay, thank you. So, so another question from my side. Let's say when you drive a car, if you increase the speed, if you increase the speed, the average of the car, the mileage of the car will decrease or increase. Everyone, will it decrease or increase? Decrease. How you can prove it? How you can prove it? Okay, I also agree that it will decrease. But now my question is how you will prove it? By taking data. Okay, let's say I got this data. You have this speed and you have the mileage. You got this data. Now how you will prove it? So you'll be applying Pearson correlation. You'll be applying Pearson correlation formula. Again, mathematics. You'll be applying the Pearson correlation formula, again the mathematics, and when you will calculate the correlation, if the correlation value is greater than 0.85, if the correlation value is greater than 0.85, it is what? It is strongly correlated. Yeah. And if it is less than 0.4, this is weak, there's a weak correlation. There's a weak correlation. And if you find out the value between 0.85 and zero point 0.4, it means there is a moderate correlation. Yeah. So again, mathematics. Again, mathematics. So I tell you that you cannot, determine the data science. You cannot imagine the data science without the mathematics. Okay. Utkarsh sir, basically, this machine learning comes inside the data analytics. This machine learning comes under the data analytics. Basically, what happens that, as I've said to you that, okay, let me tell you again. I'll explain this part. Can anyone tell me what are the different stages of analytics I was talking? Stages of analytics. First one was what? Descriptive analytics. Yeah. What was the second one? Who will tell? Diagnostic. Thank you, ma'am. What is the next? Predictive and prescriptive, isn't it? Now, see, when you work on the first two stages, when you work on the first two stages, this is the job of what? This is the role of a data analyst and or business analyst. When you work on the last two stages, the job is of machine learning engineer. Yeah. And when you work on all these four stages, when you work on all these four stages, your job is as a data scientist. Yeah. So it means, if you're working as a data scientist, then automatically you're working as a business analyst or a data analyst. Fine. Even, let's say you have your university data. Let's say semester result came out. You are doing the analysis of the student results. That is also, at that time, you're acting as a data analyst. But yes, now you can think, see, what is the average percentage in the third class section A? Or what is the highest marks got in the math subject or in the computer subject? What is the minimum? Isn't? So this is what? This is again the mathematics working behind, and actually you are doing the analysis. So I hope somewhere this has answered your question that ML was replaced by data analytics or not. So no, ML have not been replaced. What is it? Yeah. Okay. So, I tell you another thing. There's a concept of collinearity. Do you know it? There's the concept of collinearity. Do you know? Yeah. Can anyone tell me what is the meaning of this? What is the interpretation of this y equals to f of x? What is the interpretation of this? Yeah. What is the meaning of y equals to f of x? It means y is functionally dependent on x now. Yeah. That means the y will change if there is a change in the x. So if I represent this using the data set, okay, x1, x2, x3, x4, and y. Yeah. So here, this y is your dependent variable, and these are independent variable. And there should be a strong correlation between y and x. But in the same time, there should not be correlation between the independent variable. There should not be correlation between the independent variable. If there is a correlation between the independent variable, so we say that our data is suffering from collinearity. Our data is suffering from collinearity. And this is the problem. This is the problem. Because of this, your model may or may not do the appropriate prediction. Your model may or may not do the appropriate prediction. So it means we need to deal with it. And in this case, what we can do, we can reduce the number of columns. We can reduce the number of columns, and just to reduce the number of column, there's a concept to work behind it, and that is called as PCA, Principal Component Analysis. And what is the beauty of this PCA? Yeah, what is the beauty of this PCA? PCA reduce the number of columns without removing any column. Yeah, it reduces the number of columns without removing any column. This is the beauty of the PCA. Yeah, this is the beauty of the PCA. So can anyone tell me what is the mathematics work behind the PCA? Exactly, Vijay sir. There is a eigenvalue vector. There is a eigenvalue vector work behind it. It means I tell you that you cannot reduce the number of columns. And yes, if you want to have the effective analysis, you will have to reduce the number of columns. Yeah. And if you want to reduce the number of columns, you have to apply this PCA. You have to apply the PCA. It means you are applying the eigenvector and eigenvalue. Yeah. Yes. Yes. So it means what? See, whatever you are demonstrating, whatever you are telling, actually we as a data scientist using it. Yeah. And right now, data science has changed the world in form of any, recommender system or in the form of the chat GPT, whatever you are saying. But yes, data science has changed the entire world. Yeah. Okay. Everyone, please tell me if the x is 10, let's say y is 20, x is 20, y is 30, x is 30, y is 40. Now, what if the value of x is 47? So what will be the value of y? 57? How we came to know? How we came to know? So somewhere what you did, let me explain if I'm wrong and make me correct. Somewhere you tried to find out the dependency of the y to the x. Yeah. You find out the relation that was existing between the y and x. And your mind discovered the equation y equals to x plus 10. Isn't? And when the new value had been given here, you put it this in the equation and you got the value of y. Isn't? And this is the example of the prediction. This is the example of the prediction. Although here, yes, it's a linear problem where the equation of a straight line will be working behind. Yeah. So, sir and ma'am, whatever things we are doing in the data science and machine learning, actually, I can say that somewhere I am using the concept of mathematics in a new wrapper. Yeah. So, in another way, I can say that mathematics is coming in the new form. Yeah. Okay. So even if I show you, see, so if you're using the PCA or the matrix or that just means what? If you want to compress your images, you will have to use this dimensionality detection. Yeah. Now, What is cluster? Anyone? Any idea? I am pretty sure that you might have worked on the k-means clustering. You might have worked on the k-means clustering. Everyone, please write +1 in the chat if you have worked on the k-means clustering. Okay. How many of you know about the k-means clustering? Just wanted the response in the chat. Okay. So I tell you what is the use of this k-means clustering? What is the use of the k-means clustering? So basically, wherever you want to group your data, whenever you have to group your data, let's say, for example, yeah. So everyone, can you tell me what is the total sales of each product? What is the total sales of the each product? So for the A, 10, 10, 20, 20, 40, 30, 70. For the B, 20, 20, 40. And for the C, it's a 20. Yeah. So can anyone name this operation? Can anyone name this work that I have done right now? This was my original data. I transformed this into this one. Can anyone name this operation, this function? So basically, I grouped my data. I grouped my data. Yeah. So this grouping can be done. This grouping can be done using cluster. Yeah. And one of the very famous or renowned clustering technique is k-means clustering. K-means clustering. And what is the idea behind this k-means clustering? Clustering says that, let's say I'm creating the three group. I'm creating the three cluster. Yeah, I'm creating the three cluster. So all the data points, they are very similar to each other. They will be into one cluster. It means within the cluster, only those data will be there, which are very similar to each other. Yeah. Now everyone, how you will find out that these two are similar or not? These two data points are similar or not? How you will find out? Okay. Define a metric. Fine. Anyone else? See, on the basis of the distance, if this is that one data point, this is the another data point, yeah, if they're very similar to each other, then obviously the distance between them will be very less. And if they are far from each other, that means they are very dissimilar to each other. Neither too far nor too near. It means there's a moderate similarity. Yeah. So again, you can see that here the distance is working. And which distance? What is the distance you are working here? So that distance could be Euclidean distance. Like, if this is the one point and this is the another point. If you want to measure this distance, then the first could be, let's say this is the x1 comma y1 and this is the x2 comma y2. So how you can measure the distance? Obviously, the x2 minus x1 whole square plus y2 minus y1 whole square. This is called as what? This is called as squared Euclidean distance. And if you take the square root of this, so this is called as Euclidean distance. And if you take the absolute value of this, then this is called as Manhattan distance. Sir and ma'am, I tell you one thing. Yes, Manhattan distance. This Manhattan distance was used by Mahalanobis. That was used by Mahalanobis. I think he was the great economist. Yes or no? Please let me know. Yeah, he was a great economist, isn't? And not only this, I tell you, how many of you know about the logistic industry? How many of you know about the logistic industry? Yeah. Okay. So everyone, let's say, okay, how many of you know about the last mile delivery? Okay. So, last mile delivery is what? Let's say you have purchased something from Amazon, for example. Yeah. So picking that order from the warehouse and delivering it on the customer door. This is called as last mile delivery now. Everyone, if you agree, then please write +1 in the chat. Yeah. Okay. So, whenever you'll be working on the last mile delivery, can I say your one of the motto is to maximize the delivery? Yeah. And obviously, if you want to maximize the number of delivery, your route should be optimized now. Your route should be optimized. Yes or no? Yeah. And I tell you that Google have built one library named as VRP, Vehicle Routed Planning Algorithm. And this VRP, to optimize the route, to minimize the distance, it is taking the concept of the Manhattan distance. It is doing the using the concept of the Manhattan distance to minimize the distance to optimize the route. Yeah. So in nutshell, I can say now that whatever whatever algorithm in this data science and machine learning we are using, it is with respect to what? With respect to mathematics. If you say that data science is nothing, it's a mathematics, I will not have any words to deny it. I can say that yes, something extra than mathematics, that could be justifiable, but I cannot deny that the most of the things are because of the mathematics. Yeah, this is because of the mathematics. Now, everyone, let's say, you are building the predictive model. You are building the predictive model. You are building the model that will be doing the, optimization. Yeah. Let's say, for example, you build the model and you're getting the accuracy 70%. And if you're not satisfied with it, if you're not satisfied with this 70% accuracy, can I say that you would like to improve this? You would like to optimize your performance? Yes or no? Yeah. So when you want to optimize this, you'll be calling this gradient descent algorithm. This is one of the optimization algorithm that is used to improve the accuracy of the model. And that actually take the concept of the maxima and minima, isn't? You find out the second order derivative d2x dy square. Yeah, if it is less than zero or if it is greater than zero, isn't? So dear friends, if it is less than zero, so maxima or minima, if the d2x and dy square is less than zero, it is maxima or minima, everyone? It is maxima. Yeah. And if it is greater than zero, it's a minima. So obviously, what do you want? You want to maximize your accuracy. Yeah. So somewhere this gradient descent is working, and this gradient descent is taking the help of the calculus, and in the calculus, nothing, the help of the maxima and minima concept. Yeah. So see, I have talked about a lot of algorithm. I have talked about a lot of problem statement. And in nutshell, you will find out that there's only one thing which is common everywhere, and that was the mathematics. Everywhere there is a math working behind it. Yeah. So, whether we are working on the neural networks, whether we are working on the reinforcement learning or the natural language processing, everywhere, there is the concept of the mathematics. There is the concept of the mathematics. So this is what I just wanted to tell you guys. Yeah, theoretically. Okay. So this is what I just wanted to tell you theoretically. I'll just provide the slide. But let me show you the implementation of this. Let me show you the implementation of this. So give me 1 minute. Yeah. So everyone, I'm just going to show you that how basically we, the computer people or the data scientists, take this concept and do it using Python. Yeah, do it using Python. So basically, I tell you what is the problem statement here. We are going to work on the credit card data. We are going to work on the credit card data. And here, the purpose is what somewhere, first of all, we will be reducing the number of columns. We'll be reducing the number of columns using PCA, and we will group our data into cluster. Yeah. And then we will do prediction that whether the fraud has happened or not. Whether the fraud has happened or not. So this is the problem statement that we are going to carry. But before doing that, I would like to take your question. Do you have any questions, everyone? Any questions? You can ask in the chat. And another thing I tell you, everyone, that see, let's say yeah, okay. Okay. So What are the mathematical changes we face in the industry? Okay, very good question. Anyone else? So one question I got. Another question? All right. Okay. So two question I got. I'll answer both of them. So first of all, yeah, I'll talk about it. Okay. All right. So right now, at this moment, I'll be taking these four questions. So the first question is that what are the mathematical challenges you face in this industry? I tell you that the most prominent challenges is the normalization we do. You must be knowing this normalization now, making all the data between 0 to 1, the min-max scalar. Yeah. Not only this, the main challenge is that we will have the large data, isn't it? I tell you, if when we were doing the analysis of the SBI data, it was 30 lakh rows. We had 30 lakh record. So what we did, we just took the concept of sample here. We did sampling to work on it. Yeah. And might be I may have the outliers. I may require to do the one-hot encoding. So these are certain mathematical problem challenges we face. And not only this, if related to the optimization problem, yeah, we may have to do the optimization for the high dimensional data. Yeah. Whenever we work in the predictions, like, we are working on the regression or the classification, in that case, this uncertainty quantification is really very crucial. So there are a lot of challenges, and I tell you that whatever challenges we are facing, that is actually the mathematical changes, Professor Sonu. Yeah. So, like, sometimes we may get the small sample size. Sometimes the samples are very big. We need to create the data of it. Yeah. Somewhere we have to, do the trade-off between the bias and variance. So I hope I have answered your question. Yeah. The most effective way to learn the Python is I'll suggest you that pick up any project, and start working on it. And in the same time, if you want to learn the concept, you can have the w3schools.com. This is really a very good website for the beginner, as well as you can refer the O'Reilly book for data science. O'Reilly book is really very awesome to learn the data science concepts using Python. And if you want to learn the statistic in very deep way, there's a Ken Black book. Ken Black book is really awesome because here all the statistic problem have been aligned with the business relevance. Whatever examples they are taking, they are basically taking the example with respect to the business problems. So, Vijay ji, you can get this Ken Black book. If you don't get, you just tell me. I'll provide you. This is really awesome book to learn the statistic. And for the Python, as I've said, Mr. Aman, you can go with the w3schools.com as well as try to get the O'Reilly book for data science. Yeah. w3schools.com, a very good website for beginner. And Kane Black, Kane Black for statistic. O'Reilly is the author for data science. O'Reilly for data science book. Data science with Python. Yes, yes. I can show you. See. w3schools.com. If you want to learn Python, yes, you can go ahead. If you want to learn SQL, yes. But I prefer only for Python. Another Keen Black for statistic. Although this is very costly book, I tell you, it is around 10,000 rupee. If you want, I can provide it soft copy. Next is I was talking about the O'Reilly for data science using Python. I'll just forward this to Jyoti ma'am, and she will provide to you all. O'Reilly for data science using Python. Yeah. So yes, this is the book that I was talking about. I really tell you that this is really very good book. Sangeeta ma'am, if you want to pursue your career in data science, I'll suggest you one thing, that yes, you should have the knowledge of Python. You should have the knowledge of the Python, as well as I tell you that, see, one is that IITs are running a lot of courses related to the data science and machine learning. You can enroll yourself in any courses and you can start learning. One thing. Another thing is that you can go to the Coursera. In this Coursera, you will find out the IBM data science professional. IBM data science professional. Uh, so this has taken the syllabus of the IBM data science, and the instructor is Ravi Ahuja. Just find out the IBM data science by Ravi Ahuja. He is a very good instructor, and you can either buy or you can go for financial aid. Yeah. So Coursera can provide you this course in free of cost. Oh, sorry. Yeah. So even you can learn in that way. All right. See, because I know sometime we have the willpower to learn, but sometime we don't want to buy any courses. So in that case, you can go to the Coursera, you go for the financial aid, and Coursera will happily provide you. And that course material is really very good. I have gone through with it, to be very frank and honest. Even to get my certification, I have referred some module of this course also. Okay. So yes, in this way we can do that. And everyone, this is my email ID. If you will have any question, or if you are working on any research and you need my help, I'll be happy to assist you. Now let's come to this code. Where is that? Yeah. So, but the class has not been over yet. Uh, yeah. So I tell you that you can see that here we are going to, import these pandas. Might be, sir and ma'am, you may or may not understand this code, but some will try to understand that why I'm trying to show. I'll just conclude this. Yeah. So see here that I'm going to standardize my data. Standardization means whatever data range you have, it will be between the -3 to +3. And then I'll be applying the k-means clustering. Yeah. So you see that whatever mathematics working behind it, it is just compressed into one word, that is k-means. And then the others has to visualize, to just showcase it. So let me read this data. Yeah. So if I just show you that how many data we have here. So what is the size of the data? You can see we have the 2,84,807 rows and 31 column. So if I have to reduce the number of columns, what I can use here, I can use PCA. Yeah. And just to group this data into the different groups, what I'll be using the k-means clustering. Yeah. So see, there are certain basic exploration. So for example, if you want to see your data, see, this is the data that we have. I will not print. So this is the data we have, is it? Since it's a credit card data, so that's why the headers have been hidden. They have been, replaced by the other name. And this is the class where the fraud has happened or not. Yeah. 0 means no, yes means one. Yeah. Okay. Now everyone, see, so like we want to, remove the column. So for that purpose, we have just removed this class and time through drop function. See, and then we are performing the standardization. You know what is the standardization? What is the standardization? Everyone, what is the standardization? So remember that function z equals to x minus mu upon standard deviation. So this is what? This is the standardization formula. And this formula is working behind this standard scale. Yeah. Okay. So, and when you'll be applying it, so it will just draw and convert your data between -3 to +3. Okay. Then what we did, we just applied the k-means clustering on this. Yeah. We just applied the k-means clustering, and before that, we are dropping all the missing values. So this drop NA is what? It is basically dropping the missing values. Okay, and then after you can see that I am going to perform the clustering. We are going to group our entire data into two groups. You see, I have put it here now, n underscore clusters equals to 2. Yeah, n underscore clusters equals to 2. So if I run this, and if I visualize this using this cluster, can you see here, everyone? So whatever you can see in this purple or the violet color, they are in the cluster 1, and whatever you are seeing in the yellow color, they are in the cluster number 2. Okay. So my question to you all, while looking at this, what is your opinion? What is your interpretation while looking at this? Any submission? Any submission? First of all, they are all mixed. And another thing you can see that there's a more scatteredness. There's a more scatteredness in the cluster which which is in the yellow, which is in the yellow color. While there's a less scatteredness, and this violet color are basically dense around these values, no? Means whatever data they are into this particular range, they're very, very similar. You see, they're simply overlapping to each other. isn't? So you are taking the mathematical concepts into here, you come up with the cluster, and we are using it for our business purpose. Yeah, yes, Ruchika ma'am. They're more dense. So see, the mathematics is working behind it, coming up with the picture, and this picture we are using for our credit card data analysis. Yeah, let me go to the next. So what I'm going to do here, see here what is there? We have two cluster, isn't? We have two cluster, let's say 0 and 1, or X and Y, and we have two class 0 and 1. Yeah. So now I'll just create a matrix to show how, how many zeros belongs to the X and how many 1 belongs to the X. How many 0 belongs to Y and how many 1 belongs to Y. So that I want to do, and it will be done through cross tab. It will be done through cross tab. So let me show you. Yeah. So see, this is the cluster label. So you can see here that in the cluster number 0, the maximum data is there. In the cluster out of no, 2,78,000 belongs to cluster number 0. Out of no, 5,826 belongs to cluster number 1. Out of yes, 328 belongs to 0 cluster. And out of total yes, 164 belongs to the cluster number 1. So how many yes we have, everyone? So total yes we have 328 plus 164. So yes means fraud. Yes means fraud. And how many non-fraudulent transactions are there? So it is 2,78,489 plus 5,826. Yeah. Yes. Now everyone, another thing. See, out of this 2,84,000, only near to 500 is fraud transaction, and the remaining are, let's say, 2,83,500 is non-fraud data. So my question to you all, is it balanced or imbalanced? Is it balanced or imbalanced? So this is highly imbalanced. Highly imbalanced. Just to make your data balanced, you should have at least 70 to 30 proportion. Yeah. So the data which is the minor data should be at least 30%. It should be at least 30%. Okay. So since it is highly imbalanced, so what we can do, we can apply oversampling over here. We can apply oversampling, we can apply undersampling. Again, the concept of mathematics. Again, the concept of the mathematics. Okay. So let's highlight the fraudulent transaction. So you know what we are going to do here. In that cluster, if it belongs to the fraud, it will be 1, otherwise it is going to be 0. In this way, we are going to highlight our fraudulent transaction. We are going to highlight our fraudulent transaction. Yeah. And if I showcase it, so I'll not go into the coding part. If I showcase this, so you can see that out of this 492, 328 are fraud detected. So if I talk about this 492 corresponding to this 492, we are getting the fraud detected 328. So 328 by 492. What is the answer, everyone? It will be, if I'm not mistaken, 66.67. Just check it out, everyone. 328 upon 492. Just tell me, I'm waiting for your call. Yeah. So it is 66.67%. Yeah. Now let's visualize the fraud versus non-fraud. Okay. The fraud versus non-fraud. So again, we are doing building the scatter plot for this. Yeah. See, so out of that 492, out of that 492, see, this all blue are representing the fraud and this red is representing non-fraud. So while looking at this data, what is your opinion, everyone? That maximum data points relates to what? The fraudulent transaction. Yeah. So in this way, in this way, I have just shown you a glimpse of thing where you can utilize the mathematics, or I can say where you can mix up the mathematics in your algorithm, and you can do the data analysis, you can do the predictions of the data. Yeah, I tell you, all of you go for railway reservation now. I hope everybody have at least one time they would have visited the irctc.com. Yes or no, sir and ma'am? You go for reservation. There is a confirmation predictions now. There is a confirmation prediction, isn't? When you click on this, what happens? They tell about the percentage, isn't Midul sir? And you know, just to showcase this prediction, they take the help of y equals to mx plus c, the equation of the straight line, linear regression. They take the help of the linear regression just to do that prediction. Yeah, just to showcase that. Regression analysis, exactly, sir. Isn't if any one, yeah, you remember everybody that if today, let's say the number of COVID patients is 20,000, so what will be the number of COVID cases in the next week? How can you do that? Or, yeah, so here again, you'll be using the regression concept. Although the pattern will be changed, it will be y equals to e raised to power x. Because you remember, the COVID was spreading exponentially. So in nutshell, I'll say only one thing, that there's no need to discuss what is the role of mathematics in today's emerging technologies. Why? Because, in one word, I'll say that this mathematics is applied everywhere. If you're using a new tools and technologies, you cannot imagine its effectiveness until and unless you're not incorporating mathematics into this. So, sir and ma'am, you will be the best data scientist because you can easily visualize that how the outcomes are coming and what is the effect of this and how the mathematics working behind this. So with this word, I'll just stop here myself. And if you have any question, sir and ma'am, you can ask. Any question? Thank you, ma'am. Thank you for your compliment. So anyone, any question? So I'm open for your questions. Okay. Okay. Actually, I tell you, yeah. So basically, I tell you right now what we are doing. I'm working on right now what is happening that Mr. Ankur, because it works on the time series data. Yeah, it works on the time series data. How we can say that ICTC prediction uses linear regression? I tell you, it works on the time series data. Okay, and this time series data taking two concepts. One, that is seasonality, yeah, and another is the trend. So, if let's say my data is going in this way, so what is the trend here? It's a beta naught plus beta 1t, and seasonality means converting them into the monthly phenomena. Converting them into monthly phenomena. So this is what. So here again, all the seasonality related to started with the January till the November. We will come up with. So this will be the equation we'll be getting to predict the next outcome. So even I tell you the simple concept moving average. Again, the mathematics. So Angur sir, this will take a lot of time to explain this, but yes, this is the equation that works behind it. And it is somewhere you can see that a concept of linear regression. Thank you, Angur sir. Thank you. Another thing I tell you that right now what is happening, I have learners online interview data, video recording. Yeah. So for the EdTech company, what I'm doing, I'm trying to, do the video analysis of this data. And for this, I'll be building my LLM model that will be taking this video, will doing the analysis, and it will be on the basis of this interview, it will be grouping the interviewee into three groups. The high means intelligent, low means poor performance, and the moderate means we can brush up them. So here we are working on it. Completely video data whose analysis we are doing. Okay, so this is my email ID, as I've said to you. If you have any question, you let me know. I'll be happy to assist you. So thank you, everyone. Thank you, sir, ma'am. Thank you. So yeah, I've shared the email ID in the chat.
Sir, can I?
So I will just stop here.
Okay.
So thank you, ma'am. Thanks for your
Yes, sir.
invitation. Yeah.
Sir, thank you, sir. On the behalf of Indore Institute of Science and Technology, I extend our heartfelt gratitude to Upendra Tiwari, sir, for delivering such an insightful and engaging session on role of mathematics in future technological innovation. We truly appreciate the time and effort you dedicated to preparing and delivering this session. It has been enriching experience for all of us. Thank you once again, sir. And thank you all the participants for your active engagement in the second day session of a 1 week National Faculty Development Program.
Thank you.
Participant feedback link is shared in the chat box. All participants are requested to kindly submit your response before 5:30 p.m. Thank you so much, sir.